Yes, so welcome. It's good to have you here. And we're going to talk about two skills. First one is conditional probability. The second one is inference, for example, statistics. We'll spend most of the time on conditional probability. As always, we start with the hard problems. We usually do the easy problems in the first 15 minutes of the session. So that saves us a good chunk of time. I'll give you 70 seconds to try to decipher this problem.
It's good. Conditional probability.
Conditional probability, yes. So this is a nice problem if you'd like to get confused. But in order not to confuse ourselves, we'll try to focus on what we need to find. So what does the problem need us to find? It needs us to find, so if a contestant is selected at random, what's the probability that the selected contestant received a score of 5? Day 2 or day 3, given that the contestant received a score of 5 on one of the 3 days. So there is a precondition, which is in blue. Now this is about conditional probability. You would expect it. And so I think with this precondition, we need to look at the pool of all the students who received a score of 5 in one of the 3 days. And from this pool, you would choose the contestant that satisfies whatever criteria is in red. So let's start by doing that. Which contestants received a score of 5 on any of the days? So 2 contestants received 5 out of 5 on the first day, 2 on the second day, and 3 on the third day. So the total is 7. So we have 7 people who got 5. Let's say got 5, and so we're selecting a contestant with this precondition. So any contestant we will choose will be 1 out of these 7 people. Now let's take a look at the red precondition. First, this is the blue part, and the red part is saying, okay, the probability that the select contestant received a score of 5 on day 2 or day 3. Okay, let's take a look at how many contestants received a score of 5 on day 2. How many is that? 2. Hi, it's good to see you. And how many contestants Receive a score of 5 on the third day. Okay. So we're looking at 5 contestants out of 7 statistic. And this is actually going to be the answer. So it's going to be, we're going to divide 7 by 5. So this is, I think it's called the frequentist probability. You count the number of outcomes and you count the number of instances where this red condition will be satisfied, and you divide this by it. And you assume that, you know, if the contestant is selected at random, then they all have the same chance of being picked. But maybe I'm being a bit picky about the definition. So that's that's something. If you didn't really get that, it doesn't really matter. Here we have another question. So maybe you can try to give it a try. Do you know which blood type you are?
O minus or minus?
I don't know. You should tell me.
No, I'm saying it's either O minus or plus.
And you?
Which is more common?
You're O plus. What about you?
Actually,
I don't know.
I think it's A minus, but I really don't know.
O plus is the real one.
I don't know. No, this is a medical fact that you really need to know about this. And I'm not sure. I think it's O, but I could be totally wrong. But do not let this distract you. You should focus on the question. You know, because that's what the SAT do. I'm the SAT right now. I'm distracting. So don't fall for my tricks. Now, conditional probability again. You use a certain precondition. You look at a certain subset of all the outcomes, so to say. That makes sense. I'll actually wait until somebody has this answer. Ah, that was fast.
I think it's 8.
8. Like 8?
The value of X.
Interesting. Would you like to walk us through this?
Here, the probability that the person has blood type B is 1/9, and
Okay.
they're in the negative, but it also has the negative factor. And there's 2 people that are type B that are negative, and if you know that the probability of it being type B is 1/9, then the total people with negative has to be 18. So that 2/18 is 1/9.
2/18 is 1/4. So the total number of people is 18.
The total number of people with the negative factor is 18.
Mm-hmm.
So
So 2
7
people.
plus 2 plus 1 is 10. So X has to be 8 for B to be 1/9. That's the probability.
7 plus 2 plus 1 plus X has to be 18.
Yes.
Ah, I mean, that's a really good way to think about it. Because, and it is actually a good way to approach the problem, but do you think this is also correct?
Yeah.
I mean, you can disagree. It's fine. I mean, it does make sense, and it is actually correct. And if you just take a look at it for a moment, and so I'll just say a few words. So the reason why we take a look at this block utilize this fact as the following. So out of 11 people, the probability that the person so we choose this person from all the people who have a rhesus negative. So we're looking at, this is the precondition, this is the blue precondition, just like in the previous problem. We're only looking at this subset because we're not choosing someone from all of the pool of people, but we're looking at this subset. And then, okay, this 2 is 1/9. Then 7 plus 2 plus 1 plus x is going to be 9/9. Right? So it's $18 people total. And then you just sum up the numbers and then it works. But yes, this is very good. Agam, do you agree with this?
Yes, I do.
Oh, okay, that's good. But feel free to disagree if you feel like you just want to do something else. Okay. So we have another exercise. I'll wait until somebody has a solution. Remember, there's always a precondition which needs to be fulfilled.
Just convert the percentage to probability.
Yes, that's probably a good idea. I have to be careful because this is kind of ratio between things. Okay, maybe I'll start. Put up something. So first off, we're choosing a person from all the people who preferred picnics. So this is our pool. All people who prefer picnics. This is all people who prefer picnics. That's the first fact. Now, what are we looking at? We're looking at probability that the person responded by email. Here we can see that 5% of the people who who said we want to go out on a picnic, made that clear by medium of an email. and 20% made the same assertion using their phones. But I would like to draw your attention to this very specific fact. The number of email responses was twice the number of phone responses. So here we talk about percentages, but we didn't talk really about the frequencies. You could be top 10% of your class if you're the first one in a class of 10 people, or if you're 10th in a class of 100 people. So these are completely different things. Now here, the amount of email responses is twice the number of phone responses. It's really the fact. And the reason why this is key is because this 20% of the people, let's say P people responded by phone. Then for each person who replied by phone, we had twice of the same amount of people who responded by this 5%, if that makes sense. So the total is what? It's yes, this is 20%, but the weight it carries is different. So this 20% is on half of the people. We give it a weight, something like the weight of a third. And the other one, you kind of give it double the weight because there are double more responses. Yes, it is 5%, but you give it double more weight. So when we do this, we write, okay, 20% and twice of 5% is 10%. So we have 30 P%. This makes sense. So now we ask the question. This is all possible outcomes. This is the pool that we're looking at. But how many of these people replied really by email? It's a third. That's actually the answer. So the answer is a third. If you want to make this very precise, you say, okay, 30% of the people replied, and those who replied by email, they were twice of the people who replied for a picnic. Twice of P times 5% is 10%. So I think the math wording is a bit confusing. Maybe that's an error on my part. But if you think about it for a moment, yes, this is 20%, and yes, this is 5%. But this is 5% of twice the population that replied to the picnic. And that's why we give it double the weight. So we give the 5% double the weight, because the 5% was out of 10 responses, but the 20% is out of just 50. So I hope that clarifies it. And if you have questions, you can definitely discuss them. If you don't, we can move on to the next one. Egan? Is this good?
Yeah.
Okay, great. It's so funny. I think there's not a single multiple choice question. Okay, maybe we'll look for one. Okay. This looks good. Ali, this is your good day. You can guess. You can guess.
C, answers.
C. Okay, Ali said C. Let's see. Let me know when you get an answer, like a real one. always focus on the precondition. What do we need to find?
I say B.
You say B, okay. Can you tell us why?
First, they said that they want the person to state with the state level sales tax that do not have state level income tax. So we can see that the number of states which have state sales tax are 45.
45, yes, so 39 plus 6 equal to 45.
And out of them, only 6 do not have income tax.
Out of them, only 6 do not have state level income tax.
Yeah, and 6 of 45 is 13.8%. It's like 3.95 something. Also, C is close, but B is close.
So we're looking to the nearest tenth of percent. It's an
So,
approximate.
yeah, I say we need more.
Yeah, this makes sense. Do you agree with this?
Yeah, I
Oh,
say.
you agree with this because it's your answer. But
Yeah.
I mean, do you agree with this?
Yeah, sure.
Sure. I thought your answer was C initially. You guessed it was C. Interesting. Egan, what do you think?
Yeah, I think it's right.
Yeah. Okay. That's it. Yeah. So that's just the answer to the question. So that's good. And this is funny because I think we're going to do lots of exercises today. By the way, you can unmute yourself and talk. We can all hear you. But if you, let's say, you want to participate in any capacity. So always focus on the precondition. I'll wait until somebody has a solution. So they're feeling generous. Yes.
D.
D. That's C. Why do you think this is the answer?
The precondition is people who asked about his or her bill who also asked about repairs.
So which one is the precondition?
Precondition is
So the subset of people we're looking at.
people who asked about the bill.
Yes.
Yeah.
So we're looking at people who asked about their bill. This is the subset of people we're looking at.
I say C.
Say C. Okay. I don't box it because it's the correct answer. I just box it. You have suggestions. Okay, let's go on. And you were saying
I
This
don't
is-
say that anymore. I made a mistake.
well, let's see if you made a mistake. So we're looking at which type of people in terms of probability.
The people who also asked for repairs.
Uh-huh. So how many people asked for repairs?
178.
78. Uh-huh. But here's the thing. Are we looking at the people who asked for repairs in the whole data set or just in the subset of people which is in the blue box, the precondition? It's the one, the blue box, right? So yes, so it could be a bit tricky if you're not careful. But if you see it now, you always start with the precondition and you highlight the part which is relevant because we're only looking at people who asked about the bill. Then in this case, how many people of this subset of people asked for a bill?
48.
48. So we're looking at 48 out of how many people?
671.
Yes. And I'm not sure, but I think this is a small number. I don't think it's either A or C. I need to compute it. Have you computed it?
No, but what I did, like I treated 0.07 as 7%.
Mm-hmm.
Isn't that right?
It's true, yes.
Yeah, so 7% of 671 is 46.97. That's the nearest.
Okay, but why is it not 0.05?
Because it would be more fun. It would be 33.5.
Uh-huh, okay. Maybe if I have my pull up my calculator. Compute it. You can try to get an estimate. Yeah, this is pretty close to 0.07. This is good for the purposes we want to achieve. Okay. I think we might have time for one more problem. Let's or maybe let's yes, okay, let's do one more problem. And then we move on to the other skill, which is inference. We're actually going at a really good pace. I think we're already at 5 questions, 30 minutes. It's good. When you're able to achieve more things. Good starting question is to ask yourself what the precondition is. Then you just look at this very specific subset.
Okay. 2.5.
2.5. This is a probability.
They said that they want it as a decimal.
Probability 2.5.
Yeah.
So probability greater than 1.
Small weight.
Yeah. Probably not. But you can start by asking yourself what is the precondition here? Do you know?
I feel like it might be opposite of what it's saying, that the precondition is actually starting with people who are above 10 years of age, but I could be wrong about that.
Yes, I mean
0.40.
I'll write this on the site, and maybe I'll continue this discussion. So this is good. So you're saying every single person who's has an age that's greater than 10 years.
That would be the precondition.
So this is our subset of people.
Yes.
So it's kind of, yes, so it's a bit more implicit, but this is what the question is asking.
No, that's what it is.
Yes. And so this is a good start. Now, what is this that we're looking at? We're looking to find probability of selecting a participant from group A. These are all the participants from group A. But we only look at the, could say, the intersection of these two boxes, if that makes sense. Only interested in what is inside of these two boxes. So I start with the question, how many people are at least 10 years of age?
60.
People age 10, this is 60 people. This is clear.
Yes.
And on top, we're looking to find people from group A. So how many people from group A are in this
24.
24? Are you sure?
That-
14 plus 9.
Yeah,
Yes. And let's see what this gives us. Yeah. So, I mean, this could be your answer. If you're on the SAT, I recommend you just try 23 over 60. So your
I
answer.
look 24 over 6, let's say.
Yeah, so that's the problem, right? So you do all of this here. You're doing great at the problem. You make the right conclusions, but then maybe you should have used that
I saw it as 15.
for the conclusion.
Yeah.
Ah, okay, that's fine. It happens. Yes, so you could write it in the exam as 23 by 60. It's acceptable. I think also 0.3833 is acceptable as a solution. Or 0.383 and so on and so forth. This is very good. We did almost all of the exercises for conditional probability. To conclude, we just need to focus on the precondition and which subset of people we're looking to study. Study is a good word.